So today discuss about the second type of problem where the bolts are arranged in chain form. Okay, so I will read the question first. Determine the design tensile strength of the plate 120 mm into 8 mm connected to a 12 mm thick gusseted plate with the bolt hole as shown in the figure. The Fi is given 250 Newton per mm square and Fu is 410 Newton per mm square. The diameter of the bolt are 16 mm and the diagram also shown in the diagram also shown. Okay, when you refer the diagram, you can see we have 6 bolts. The pitch between the bolts are 60 mm and edge distance they given actually 30 mm. The problem is type 2 problem. In this we have to calculate first thing given data, then you have to calculate yielding of cross section, then we have to calculate rupture of cross section, and we have to calculate blast shear. The value you have to compare all these three. Which value is less, that is your tensile strength of the plate. So we will start with first one is given data. What is given here? When you refer the diagram given, actually the given plate size is given 120 into 8 mm. Okay, then Fy is given 250 Newton per mm square, and Fi also they given, Fu also they given 410 Newton per mm square, and they also given bolt size is 16 mm they given, then whole side D0 is equal to 18 mm. Okay, so now we require actually gamma m0 and m1, but we already discussed, we already know how to calculate and where you get the value of gamma m0 and gamma m1. Gamma m0 will get from 1.10 and gamma m1 is 1.25. We will get this value from page number 30. So now what is the tensile strength of this? So we have to calculate first yielding of cross section. So we have to calculate yielding of cross section. So yielding of cross section by referring page number 32. You know already formula because we solved one more problem last class. So TDG is equal to Fi Ag divided by gamma m0. So when you substitute the values, you will get the value is 218.18 kilonewton. Okay, second thing we have to calculate rupture of critical section. So we have to calculate rupture of critical section. That also you know in the last class once that given TDN is equal to 0.9 Fu An divided by gamma m1. So what is An here? So An you already know, there is no zigzag bolting here, so you directly take as B minus NDH into T. So what is B value? B value is given 120, and N number of bolts we have to consider only any one section. So it will be 1 or 2. So it will be always, if you consider this section 1, so it is only consists of 2 bolts here. So we will take as 2 into 18, and thickness of the plate is given actually here is 12 mm, the minimum is 8 mm. So the value will get 672 mm square. Substitute this value, you will get the TDN value is 193.54 kilonewton. Now third step, we have to calculate blast shear failure. This is only actually important here. You have to understand this first. Okay, so by referring the diagram, you can refer here. If you draw a small diagram here, this is bolts. How many bolts are there? Totally 3 bolts. Okay, so now next again repetition same. Here also we have 3 bolts. Okay, so what is the dimension of these bolts? If you arrange here, you can see the pitch is given center to center is 60 and edge distance is given as 30 mm. Okay, so now here we have to calculate the values of TDB 1 and TDB 2. So TDB 1, the formula is given actually AVG Fy divided by root 3 gamma m naught plus 0.9 ATN Fu divided by again gamma m1. Here is gamma m naught and here is gamma m1. Or one more formula they given actually TDB 2 is equal to 0.9 AVN into Fu divided by root 3 gamma m1 plus ATG Fy divided by gamma m naught. So we have to calculate ATG, AVG, ATN, and we have to calculate Fu and Fy is already given in the problem. Now we have to understand how to calculate. First one is AVG. What is AVG? So AVG, AVN, ATG, ATN. You just refer the code book, page number 33, you get the expression in the theory. Okay, so page number 33. Now what is AVG? I just calculate how you calculate AVG. Here just see the diagram, 30 plus 60 plus 8. In this only the maybe shear failure will occur. Maybe shear failure occur in this side only, so that's why I have to consider this area only. So here we have to add first 60 plus 60 plus 30, so total is 150 into we have to multiply with thickness, but here just check, here we have two planes, one and here is second, so this is first plane and second, so we'll multiply with 2. So total area will get here 2400 mm square. What do you mean by AVG? AVG means we have to consider whole area of blast shear, where the blast shear will be occur. It means that we are not considering all the area of blast shear without detecting the holes. So AVN means what? Now what happened? You consider total area. Now we have to remove how much number of bolts are placed. Okay, so now if you check here, so you already know the thickness is 150, is already 150 minus how many bolts are present here, 1, 2, and this is half, this is 1 bolt, second bolt, this is 0.5, so it is 2.5. What is the size of the hole? It is 18. Multiply with thickness, and this whole multiply with 2. Why it is